right, super. All right, welcome everybody. Super excited for everybody to be here. This is actually the inaugural cybersecurity forum. So first time we've had this as a dedicated forum, which is really exciting. So this week we are bringing together the greatest minds in AI and cybersecurity. And we have a packed agenda this week. I think we have almost 20 dedicated cybersecurity sessions throughout the forum, the breakouts, and that's not including all of the Unity catalog and governance and AI security sessions. So very exciting. So my name's Taylor Kane. I am the head of marketing here for cybersecurity at Databricks. And we have a great slate of 3 different companies today that you're going to hear from. So just real quick before the speakers come up, just very excited. Ali this year at our all hands to kick off the year really drew a line in the sand and said, look, cybersecurity is a strategic growth driver for the company. It's going to be a primary kind of new strategic pillar, and we're all in on cyber. And one of the main ways that I see us driving usage and use cases is through our partners. And we have a very robust partner ecosystem of ISVs and GSIs, and you're going to hear from some of those today. So we all know that there's a paradigm shift happening in cyber, right? Data's exploding, AI's everywhere. Analysts are being asked to do more with less. And I really view cybersecurity as a data problem. And I believe there's no company better positioned in the world than Databricks to help meet that need. So first we're going to hear from Jiong from a company you may have heard of, Wiz. So if you didn't know, Wiz got interest from Google earlier this year at $32 billion. They're the fastest growing cyber company ever, from 1 to 100 million. They did that in just 18 months. And so she's going to come up and talk about securing Databricks with Wiz. So let's give her a warm welcome.
Thank you so much, Taylor. And I'm incredibly excited to be here with you all today. I'm particularly thrilled because I think it's probably safe to say that the folks in this room are doing amazing things when it comes to data and AI and empowering their businesses. And I'm really excited to give a sneak peek of actually a very close partnership that we've been incubating with Databricks that's really all about helping us to secure Databricks in the same way that we understand our cloud environments. So just for those of you in the room that may not be familiar with Wiz, really, we're a cloud security platform. We're really focused on enabling security teams to actually hit their security outcomes, enabling them to remove critical risks from their environment and democratizing out to the business teams as part of that process. We feel very fortunate to be trusted by over 50% of the Fortune 100 from iconic technology companies like Salesforce, as well as highly regulated financial institutions like Morgan Stanley and BlackRock, and really every industry in between. Now, when we think about the challenges that we consistently hear from these customers, it is really the fact that their businesses have changed. They are now technology companies. They have business units that are focused on development, focused on enabling the latest AI use cases to power new, amazing customer experiences. And as part of this shift, their dev teams have adopted an agile methodology. They write application code. They write infrastructure as code. They think about their AI applications and how they build it through the pipeline. They deploy those, it's running in the cloud environment, and then they monitor it. And these teams are going through this process faster and faster every single day. They're leveraging ephemeral resources, dynamic environments, the latest technology like Databricks to enable them to do this. Now, the challenge that we typically see with security, though, is security is still oftentimes operating in a bit more of a waterfall mentality. We have different tool sets that are owned by different parts of our teams. Application security teams owning code tools, cloud security teams owning cloud tools, our SecOps teams owning runtime tools. And all of this ultimately funnels these alerts back to security in a way that lacks context, lacks ownership, and makes it difficult to really prioritize what's really important for us to protect our businesses against. And worst of all, when we think about the cloud environment, The security team doesn't own the cloud environment. They don't own the applications. So even if they find something that is real, they're reliant on these business teams to actually undertake the fix. And when we funnel them too many alerts, we break trust, right? We erode trust between the teams, and it creates friction. And really, when we think about all of what is happening in this environment in terms of the transformation with AI, as well as just greater use cases, we're really increasing the complexity level of what is in front of us, right? We have AI models that we're building. They are trained on data. We have more compute resources than ever across a broad spectrum of the environment. We have more to think about in terms of who has access to that compute as well as to this data. It becomes very critical to actually think about how we are going to protect not only every individual layer, but the entire environment as a whole. So fundamentally at Wiz, we believe that we need a new operating model for cloud security, one that flips the story, one that means that we are operating security in a horizontal manner that reflects the agility of our development teams. That means connecting the dots as well, from code risks through the pipeline into cloud risks that we then monitor for ongoing risks. And this allows us to really provide context and data to security teams to take the best action for their business. And for development teams, it's about actually finding the root cause of the problem, whether that be in code, whether that be in a misconfiguration, potentially in a data asset, but really allowing them to fix it once all the way back at the source. Now, once we know what is critical, the key is really all about bringing these teams together. Right? Breaking the silos that have traditionally existed within our organizations. So if we take a potential threat, like let's take a Databricks bucket that might expose a secret that actually would enable access into our cloud environment, which contains sensitive data. This is something that a traditional approach with silos would make it incredibly hard to pinpoint this risk. And what we want to do is not only surface it, but get it to the teams, get them the visibility so that they can do their jobs properly, as well as in the workflows that they already have. And so what this means is finally breaking these silos, treating security as a team sport. So for data security teams in that particular example, we want to give them the visibility that, hey, we are exposing sensitive data, and who has access to that data? Should that key have actually granted that access to that sensitive data? For cloud security, we want to tell them, hey, this is a complete attack path into your environment. It's something that we need to proactively remove before an attacker can exploit it. And for the AI teams that might be training their models on this sensitive data, we also need to inform them as well so that they can track their models and track risks against them as well. So when we think about Databricks, I think it would be in some ways doing a disservice to Databricks to only think about it as a SaaS platform. It does so much more, right? You're doing incredible things when it comes to the use cases that it is unlocking. It has a lot of technology components. You're building AI models within it. And so for us, the best model to use for it is to treat it just like we would our cloud environment. And so when it comes to understanding the posture of Databricks, there's really three key components. First of all, we want to have the visibility into the environment, right? Really understanding all of the data resources and the relationships between them. Next, we want to understand where does sensitive data reside within these data stores and map it in the exact same way that we would our cloud environment and understand where we might be putting it at risk. And we also want to extend this to AI as well, right? Because data and AI inextricably linked at this point. And so we want to also understand what AI risks are we introducing through our AI use cases, and similarly, understand attack paths and prevent them from being exploited. So let's dive in a little bit into each one of these. First is the instant visibility. Again, we're treating Databricks just like we would AWS, GCP, Azure, wherever you run your cloud, or in multi-cloud for most of our customers. And what we do is we scan it. And we scan it in an agentless manner using an API-based role. which means super simple to connect. You walk away, you have a coffee, you come back, and you understand every component of your Databricks environment, and we lay it out for you on the graph, right? So completely modeling out network topology, understanding the identities associated, and then we layer on the risk assessments, right? Where do we have misconfigurations, vulnerabilities? Where do we have excessive permissions in the environment? And also, where do we have sensitive data like PII, PCI, or PHI? Once we have this, it becomes so much simpler to actually map out and prioritize what is most critical for your teams to solve. So diving in a little bit more, again, sneak peek into the preview capabilities right here, you can see how we're understanding misconfigurations associated with Databricks. And we are providing out-of-the-box rules to understand these as well, working very close partnership with Databricks to define this. Also understanding a complete inventory of all of the identities in your Databricks environment and who has access to what. And also extending secret scanning to this as well. So you can see in this example, we've got the Databricks volume. It has a secret that was found within it, and this secret actually maps to this particular service account in the environment. And the crown on top of it means that service account actually has admin privileges in the environment, right? So uncovering a full lateral movement path right there. Now, the next component is layering on the sensitive data analysis. Again, this is the same DSPM that we have in the cloud environment, so you define the classification rules once and it applies across the environment, and you can understand and discover actually how data exists within, let's say, notebooks, the tables, the pipelines, and then trace the mapping between these assets as well as who has access to that data. So, taking a closer look at what this looks like within Wiz, you would be able to look at a database or a Databricks schema here. This exists on a table, and you can see we're finding 3 types of PII here: income, email, as well as names. So these are data findings that we can surface. But beyond that, for data security teams, we want to uncover more than just the findings, right? What geographies, what regions are we finding this in? And this enables us to actually govern data in a much more seamless manner and with that single pane of glass. Now, shifting into the AI side of things, we take a similar mindset where it starts with visibility, right? And so we actually have introduced what we call an AI bomb, so an AI bill of materials that uncovers every single AI service that is in use across your entire environment. Again, whether that be Databricks or whether that be with your cloud providers themselves. And because this is all done in an agentless manner, it means that if a AI team starts playing around with something new in the environment, it shows up automatically. We're not relying on them to tell us that they started kicking tires. We can just see it. And from there, security teams can make the decision of, hey, is this a service that we want in our environment, or do we want to actually review it in more detail? And lastly, this gives us the ability to really understand the complete pipeline associated with it. I mentioned misconfiguration checks earlier and having those built in out of the box. We do the same thing for AI as well, right? So you don't have to go through the effort of understanding kind of like the baselines of what is acceptable or not. We've done that already with Databricks. You can leverage them out of the box. But again, it's not sufficient to just go through a list of misconfigurations, right? It's actually incredibly ineffective. We want to prioritize because our goal is to make our teams more effective so that they can move fast. And this is where it's really all about layering on a full attack path analysis. So in this example, what you're seeing is we have a Databricks model, right? It's leveraging a Databricks data set that reads from a Databricks volume, which we see contains email, as well as social security numbers. You know, if that was it, probably not the end of the world, something important for our teams to know, but not necessarily putting it at risk, not a significant business impact. But this is where layering on the other risks becomes very important. And we can actually see that there's an endpoint that actually publicly exposes this model as well as the underlying data. So now we know, right, that an attacker could compromise this and be able to exfiltrate that sensitive data. And if perhaps there was a misconfiguration on this model so that it wasn't just read-only, but it enabled folks to be able to write to it. We would also be enabling a risk around potential data poisoning. So this is where understanding all of the risks and bringing them all together into a single view that's focused on the attack paths really comes in handy to empower your teams. All right, so I'm going to show two very quick demos. So in the first one, we're going to put on the hat of our cloud security team. Right, so cloud security teams, they want to focus on those attack paths, and they want to proactively remove the most important ones so that we're really reducing the attack surface of our environment. So in this example, what you're seeing are Wiz issues, which are the complete view, where we're looking for those toxic combinations of risk. And what you're seeing is specifically what are the risks associated with our Databricks environment. And we can take a look at here the different resources that exist, and we can even click into this one, which is actually the one we were just looking at, which is a bucket that exposes a key that enables access to sensitive data. And this would be an alert that would go out to the security team as well as the data teams involved. And you can see you can click into every single one of these components and get more context about why this is actually a risk in the environment, including actually finding the sensitive data in question and actually understanding exactly where it exists in the environment, how many records we're finding within it as well. So really giving your teams the confidence and the context to know that this is that lateral movement path that would enable an attacker to really be able to exfiltrate that data. Now, next, we're going to put on the data security hat. We'll do a very quick demo of this as well. So the first thing I'll just point out is if you look at the left-hand side, which is sort of the menu, we actually have scoped the entire platform down now directly into a view of what data security teams care about, which is where is my sensitive data and what are the risks that are associated with it, as well as how are we doing from a compliance standpoint. And so in this example here, again, we're scoped down to the Databricks environment. You could remove that filter and look at across everything. But what we're seeing here is all of the instances of PII and PHI, where it breaks down from a geographical standpoint, and then how are we doing from a risk posture standpoint on each of our data stores. Incredibly powerful information, but we can also zoom out and look at what are the risks that are associated and what are the things I really need to focus in on. Like, for example, I might actually be detecting suspicious activity that might indicate that someone is exfiltrating data from my environment. And then the last piece is really around the data classification rules. So we ship out of the box with PII, PHI, PCI classifiers from around the world, but of course, that's not sufficient, right? All of our businesses are very unique. We care about very specific things. If I am a, let's say, airline, my loyalty number is PII. I had a really interesting use case the other day where I was talking to a gaming studio. They codename all of their games. Their games are their sensitive corporate IP. And so they really want to understand where it exists in the environment. And so they actually used our classifiers to create a custom one for each of those code names, so that adds on an additional layer of that business assessment of risk in the environment. All right, so this was just in many ways scratching the surface. There is so much more yet to come, and we're incredibly excited about everything else that is coming as we progress to public preview and then a general availability, hopefully later this year. And so a few things I just wanted to point out. The first one is we're going to extend what we're doing in terms of what happens when you uncover that shadow data or shadow AI. Earlier, we mostly just saw, hey, it's here in your environment. We want to make it super easy for teams to take the action. One click wherever possible, right? Potentially remove the issue, rotate the key that was associated with it, remove the permissions, right? Make it super simple for teams to take action. Secondly, we're expanding the coverage of overall Databricks, right? So today we are not doing the compute layer, so we're adding that in. Also adding in support for the notebooks, and you might be writing code in notebooks. So we also want to extend our ability to understand the security of the code to notebooks as well. And then finally, unfortunately in cloud, we can't remove every single risk in the environment. We do have to be very aware of what is happening in real time and do threat detection. And so as part of that, Wiz is also ingesting, or soon to be ingesting, the logs from your Databricks environment, which allows us to understand, where do I have suspicious activity? Where do I potentially have a threat actor in my Databricks environment? But more importantly, correlating it with the logs that we have for your cloud environment, from your IDP, from SaaS applications like your GitHub repository, and really helping you to understand a potential threat actor and compromise that may occur across layers of your environment. And then finally, also enabling our SecOps teams to have the right playbooks to take the right action here as well. Because again, this is a very different world for, in particular, SecOps teams quite often. All right, so just in closing here, we're super excited about what this enables, because there's so much greatness that is happening within these teams with Databricks in terms of empowering your businesses. And I think never more has security been able to actually be an enabler of that vision and to enable our teams to move fast. So come talk to me if you want to learn more about the integration. We'd love to have more folks using it. All right, thank you so much.
All right, thank you. Appreciate it. So before the next presenter comes up, just something I wanted to share quickly that's exciting. Anvilogic is going to be coming up to speak. Some late breaking news that we just had. So not only is the integration with Databricks live, and you're going to hear from one of our flagship joint customers, SAP, but also we announced late last night and early this morning that Databricks Ventures is actually investing in Anvilogic, which is really exciting. Just seeing the value of that platform, as it plugs into Databricks. And also last night, they won our Data Growth kind of built on Partner of the Year award as well. So you're going to hear from Anvilogic if you guys want to come up. And you're going to hear the use case with Databricks, Anvilogic, and SAP.
All right. Thank you, Taylor. So hi, everyone. I'm Alan, and I'm solution architect at Databricks, actually. SAP was supposed to do this part of the talk, but the presenter had an issue with his travel. So now I will present on his behalf, because I kind of was there with the entire journey of adopting Databricks and adopting Anvilogic. So you will hear from me today. However, we did also a webinar with Anvilogic last week, which is live on their website. So if you want to hear the story also from SAP directly, I recommend to you to check out the Anvilogic website and also watch the webinar there. So with that having said, let's get started. So what I will do is I will share a little bit the story of SAP ECS. And Meg here from VP of Product from Anvilogic, will then deep dive a bit more into the Anvilogic product and into the integration with Databricks. So what is SAP ECS, first of all? So SAP ECS, Enterprise Cloud Services, is the private cloud environment of SAP. So it means if you're an S4 customer and you're hosting your private cloud S4HANA, then it's being hosted within ECS. ECS is providing essentially the cloud environment, the cloud infrastructure, as a service to the customers. And as such, they obviously have a lot of data, and they are responsible for the security of their customers and of themselves as an enterprise, right? So it's pretty critical for them to handle large amounts of data for cybersecurity at scale. Now, they essentially embarked with us on a journey to adopt Databricks and Anvilogic for detection engineering. And they started off with a quite classical architecture, right? They had a monolithic classical SIEM in place where they had all their detection engineering. But they had certain challenges there. So one challenge that they actually had was the development time of new detections, right? It was just too slow. So they started adopting Anvilogic on top of Splunk, on top of their SIEM, in order to, first of all, actually improve the detection engineering speed, right? So the way Anvilogic works, it actually plugs into a data platform like Splunk, and then essentially uses that as compute. So what SAP did is they migrated off their detections from Splunk into Anvilogic, and then essentially used Anvilogic as this front end for detection engineering, while still having the data feeds in their SIM. So another challenge that they later also had was actually costs, right? So SAP ECS is growing 40% in data size year over year. So this is at a multi-terabyte scale, becoming prohibitively expensive. And then they looked for a solution to essentially reduce their costs to keep the data much longer and essentially keep up with the scale of the business. So what they did, now that they actually adopted Anvilogic, they had an easy way to replace their existing SIM with Databricks as their data platform. So the benefit of that, primarily in the beginning, is really that SAP ECS can use our compute model, which is cloud native and separates storage from compute, right? So we store all the data in the object store in the lakehouse and only use the compute for a given operation. And that is much more cost effective, like we see 70, 80% cost reductions, than using a classical on-premise type architecture where you have coupled storage and compute. So that was really the driving factor for ECS to adopt that. But now they also have an environment that is much more flexible. So they're not using Databricks only for detection engineering, but they're actually, for instance, also building a new product. It's called SAP Raven, based on that data, right? Where they can actually expose the data to their customers, where they also create insights for their customers, everything in Databricks. And now they're also embarking on a journey to adopt custom AI use cases. So for instance, I'm currently working on a use case where they want to classify an alert with an LLM into certain categories, right? They now have a team that actually is able to work in Databricks, to do data science in Databricks, and to build custom use cases for their security operations. And that is really the power of this new architecture. It's on the one hand a much more cost-effective way of doing cybersecurity. It is opening up really the architecture for many, many use cases, AI use cases, analytics use cases, new data products. And at the same time, using a tool like Anvilogic, they actually bring in cybersecurity logic into a general purpose data platform that it otherwise would not have at that scale. And with that, I'd like to hand it over to Mac to tell you a little bit more about what Anvilogic actually is. So thank you.
Thank you, Alan. And first, I just want to say thank you to SAP for being a great design partner with us on this integration, and definitely thank you to Databricks for working with us the last 6 months on building out our detection engineering and triage platform on Databricks. It's been a really awesome experience, and we're really excited to share some cool use cases and things that SAP has done on top of that data that now sits inside of Data Lake. So kind of what we're seeing is this new era of what we're calling SIM modernization, right? And what a lot of organizations are starting to do is they're starting to move away from those monolithic platformization-like concepts like your traditional SIM, right? Like Splunk as an example, for all the reasons Alan just said, right? Cost obviously is a big reason, but also the analytic capability, the scaling capability, the use cases that you want to do in something like Splunk does not scale, especially when you want to start to do data science or anything related to AI. So what we're starting to see is this kind of best-of-breed environment where organizations are choosing tools like streaming tools like Cribble to figure out where they want to move data to, right? Storage services like S3. We've been helping organizations run the detection engineering and triage process regardless of where that data lands from a security perspective, right? So if you want to use Splunk, you can continue to use Splunk. If you want to use Splunk and Databricks, you can do that, right? You can have a hybrid model where you put some of the larger data feeds into something like Databricks so that there's cost effectiveness, but also you can start to scale some of those larger use cases. And then you can plug and play whatever type of respond or SOAR capability you want at the back end, right? So now you have this environment, instead of having this monolithic, one vendor does it all, you can pick and choose the best of breed technologies that fit what we're saying is kind of the core workflows inside of the SIEM architecture, right? And obviously the cost benefits are awesome and amazing. Like I was saying before, customers are saving about 70% on average when they move to Databricks, when they're removing that data from Splunk. But also the analytic capabilities that you can scale inside of those systems is just far superior as well. So what specifically do we do inside of Databricks, and how do we kind of architect our solution inside of the Databricks environment? So what we do is we spin up a Databricks catalog, right, that contains all of our code that we use to run the detection engineering process. And the very first thing we do is we deploy notebooks down into create basically DLT tables to help with the parsing and normalization of the data that people want to bring into Databricks for the security use case, right? So we'll give you that Python code that helps with normalizing that data. We normalize into basically into our gold standard tables. A good way to think about this from a security side is we're moving a lot of data into one standardized place based on data domain. So simple example, you probably have 5 or 6 endpoint feeds. Like SAP has multiple endpoint feeds. They have their EDR feed, they have Windows security event logs, they have their Linux event logs. We're taking all of those, we're parsing and normalizing, and we're storing it into one gold table called endpoint, right? So it has multiple sources in there. That gives you a lot of power and flexibility to kind of organize data by domain. And that's what our process helps to do. It's totally flexible. You can update those parsers, code control it, and then deploy those out so that you can get that data ready for detection engineering. And then what we have on top of that is our detection library of detection use cases that basically is converting SQL to PySpark and then deploying that down into your Databricks environment as a workflow job, and then those run on whatever defined schedule that you have specified. So in the SAP world, right, they're bringing in all that data from their storage services, we're normalizing, landing that data into our gold tables, and then they're deploying and building detection use cases using Anvilogic, and then deploying that across the Databricks environment, and still deploying some across the Splunk environment. So they're able to have one analytic layer for detection engineering, regardless of where that data actually lives. So that's our architecture inside of Databricks. I'm gonna walk you through a simple demo on kind of how this works inside of Anvilogic, so you can start to see how fast customers like SAP are building these use cases inside of Databricks. So I'm just gonna play this video here. Perfect. So like I said, we have an armory of detection use cases that you can deploy inside of Databricks. So if you have ideas in mind, or you have data that's inside of Databricks, we have thousands of out-of-the-box hunting queries that you can use to begin to deploy those detections downwards. So SAP was able to, within a couple of minutes after getting set up, deploy all of those analytical use cases across their endpoint and cloud feeds. We also keep all that content updated. We stay up to date with all of the trending topics. So we give content packs out to our customers who are trying to build detection use cases across complex attack patterns. Another amazing thing about this architecture is we can build these sequential stages of an attack, regardless if that data lives in Splunk or if it lives in Databricks, right? So you can cross-correlate your detections in a more of an attack path specific scenario, even if that data originated from Splunk or if it originated from Databricks. Now, when you want to go build a detection in the data that lives in Databricks, it's very, very simple to create a detection, right? We have a search agent that's going to help you with understanding where that data lives. So in this case, I'm just looking for encoded PowerShell commands. What that's going to do is find the data, the gold copy table where that data lives, give you some output. You're going to be able to directly search that data that's sitting inside of Databricks and bring that data back. This is nice too because you have the same interface as you would for Splunk, so you can kind of keep everything consistent from the UI perspective for your detection engineering team. You can also analyze the events that you're seeing directly inside of the product as well. So if you wanted to take a look at an encoded command, figure out if that's actually malicious or not, right in line as you're building the use case, that's a really popular example of how customers are doing a little bit of hunting and exploration as they're building out those use cases. You can tell the agent to decode that command for you as well if you want to get an understanding of what it actually is. Being able to kind of, I would say, transition from some of those languages like SPL into SQL is not as easy for some customers because they're kind of trained their employees on how to use SPL. So this really helps organizations start to kind of move towards SQL, right, and making it less of a barrier to entry when you're building those use cases out. So once you have your detection kind of built, let's say you're ready to go, you want to deploy this down into the environment, this is where we start to get into the detection as code framework. So up top, you can kind of create that. We call it a threat identifier. It's just a use case. But this is where we're actually converting it to PySpark, right? So what we're doing is we're taking that SQL, we're converting it into our detection as code framework, which is a layered way to build detections that standardizes detection writing across any of the data platforms that you're deploying to. And in this case, what we've done is we've actually created a detection now that will execute as PySpark inside of Databricks once you go and deploy that. So you can create the use case, it gives all the documentation for you, applies all the tags, gives you that standardized detection logic builder, and then you can deploy that out down to your Databricks environment, and that will run on whatever defined schedule that you've put it to run on. So SAP has been able to basically reduce the time it takes to detect from days to build new detections down to about a couple of minutes, and in some cases a couple of hours. And they've been able to build a lot of new detection use cases, version control, all of that, keep it all organized across the use cases that they have in Splunk and the use cases, the newly created use cases that they now have inside of Databricks. So just to summarize, right, how we've been working with Databricks, we're kind of reducing that SIM lock-in, right, being able to pick and choose what data platforms you want to use from a security perspective without disrupting your team from a detection engineering, triage, and hunting perspective. The mean time to detect, right, your ability to build detections faster and scale those detections is far superior inside of platforms like Databricks, which we're really excited about. You can basically start to modernize your security operations center to become AI ready as well, right? Because a lot of those use cases that you run that maybe you were trying to build better baselines in Splunk that weren't able to scale, you can scale those now inside of your data lake environments and really begin to build really, really powerful detection and hunting use cases. I do want to, like Alan was saying, we did a webinar last week with Roland, who basically was bringing these two companies together, Anvilogic and Databricks, to build this solution for them. He's been on the forefront of innovation when it comes to taking the ECS environment and modernizing that architecture. So just really wanted to appreciate, just say, thank you to Roland and SAP and to Databricks for working with us on this integration. It's been a great journey, and we look forward to the future.
All right, thanks, Mac. Thanks, Alan. All right, so last but not least, Anil, you can come up. So Anil is from Capital One. They're a great partner. I think they actually have the record for the most attendees here at Data and AI Summit. I think they have like 130. But Capital One's doing some great things with Databricks. So Anil, I'll pass it to you.
Awesome. Thank you, Taylor. Great to be here. Thank you all for coming in. My name is Anil Chamarthy. I'm a director in cyber engineering at Capital One. My teams, we build platforms and capabilities to help detect and mitigate cyber threats. Let me go next. So here's what I'm going to cover today. I'll start off with what a SIM does at a high level, challenges that we faced with the legacy SIM, and our modernization journey, mostly from architecture and engineering standpoint. And finally, I'll touch upon how we migrated this massive inventory and key learnings to share. Let's just jump right in. SIM. So at its core, SIM is a platform that ingests a lot of telemetry data, and it runs detection logic, and it correlates data to find a potential cyber threat by basically answering the question of who did what, when, and where. But to do this effectively, it needs to handle high velocity logs, and it needs to run pretty complex detection logic and correlating events across sessions, users, hosts, just to name a few. And at Capital One, as our environment grew, our telemetry grew. So right now, we manage a pretty large lake for the data. dozens of petabytes. We had hundreds of terabytes every day, with billions of events flowing through every hour. So pretty data-intensive lake architecture we have. And our legacy SIEM, it had 3 core challenges. It wasn't designed to handle this kind of a scale. First is, let me go there. OK, so the first one is the data schema side. So at that time, we had like a suboptimal schema, I should say. So it was hard to stitch signals together across telemetry. And that led to like poor user experience, and we couldn't like write consistent detection logic. The second one was, we heard it before, mean time to detect. In cyber, that's pretty important. So because of our batch nature of the legacy system, it was taking longer than what we would have liked for detecting a threat. And our principle was to move towards a streaming detection engine. And third is the cost. We were moving massive amounts of data from point A to point B to run the detection workloads. And our principle is to not do that, don't duplicate the data, but instead bring the process to the data. So now that we talked about the challenges that we have, now let's talk about like, how the new system looks like. So this is the high-level architecture view of our end-to-end streaming threat detection system. So to your left, you will see like all the raw events flowing from network, systems, applications, just to name a few. They all land in our centralized data pipeline. And this pipeline, it standardizes the data, and it rationalizes it, removing the noise, and it enriches the data as needed. And on the right, and it lands in Delta Lake, which is our single source of truth for all cyber log data. And on the right, we have our detection system, which is our streaming engine. It stream reads all the data, applies the detection logic, and it continuously processes the events to create the alerts on the right. So this streaming native engine really helped us with detecting the threats in a near real-time fashion. So to build the solid data foundation, there are 2 things that we focused on. First is we adapted Elastic Common Schema. And that really brought us a consistent field semantics to our data, which was very critical for us. And it also enabled us to write a consistent detection logic across telemetry. The second is storage layer. So Delta Lake. We chose Delta Lake as our storage layer. So previously, we used to store the logs in Parquet zones in S3. From there, we copied it to data warehouses. And sometimes we even copied it to some local places just to solve some niche use cases. So we moved away from that model. Now we use Delta Lake, which really gives us like a unified and scalable place where we can land the data, and not only land it, read it very fast. That was very, very critical for us. So moving to the right side of the picture, which is the detection side, right? As I mentioned, consistent data lands in Delta Lake. It really powers our, our detection engine. And we did some intentional partitioning, like optimizations on the Delta tables that really helped us with powering various aspects of the engine, like streaming reads, scheduled reads, many different kinds of reads. And more importantly, there is no staging, there is no duplication. It's just clean, direct reads from a single copy of data sitting in our Delta Lakehouse. So now let's look at our framework. This is where the intelligence lies. And this empowers our threat analysts to focus on writing the threat hunting and threat detection logic by using the capabilities of the framework. And I'm going to talk a little bit about what are the key functions of the framework. So the first is the modularity of the framework itself. It greatly simplifies our detection writing process. The second is noise. So in cyber, like you want to know exactly if there is a threat, right? You don't want to keep hearing every minute. So our suppression and debounce logic of the framework helps us manage that noise. Third is the table builder. There are many use cases where we want to build like time aggregates, entity tables, et cetera. So we use table builder function for that. And unit testing. So we treat detections as code. So we write unit tests against it. That's something that framework enforces each detection to have. And finally, MITRE mapping. So every detection has tactic and technique assigned to it so that we know the coverage of our threat surface. And above key functions enabled us to write diverse and highly complex detections with speed and confidence in operationalizing them. Third is detection as code. We made a strategic shift in how we manage our detections. So every detection in our inventory right now is version controlled. It has full unit integration testing, and it's backed by a fully automated CI/CD pipeline. So this engineering rigor really helped us with like vastly improved detection quality and the speed we need to deploy the detections to production. This is like a template of our how high-level detection looks like in our world. At the top, metadata, like name, ID, severity, et cetera, followed by a place where we plug in the detection logic for what we are trying to find. And it has MITRE mapping taggings that we see. And finally, unit tests to make sure that we are testing every aspect of detection to make sure the quality is high. And underpinning it all is our real-time processing at massive scale. So every detection runs as a Spark structured streaming job in our Databricks cluster, processing millions of events per second and across all our telemetry to find the threats we have. Bringing it all together. So what makes this powerful, this platform powerful is the seamless abstraction. While our threat detection authors, they're focusing on the actual detection logic, the platform handles like all the complex orchestration we have for the jobs and all the scaling and infrastructure needs that we need. This modernized platform built on Delta Lake and Databricks enables us to find near real-time threat alerts in safeguarding our Capital One environment. So it's great. So we talked about architecture. Now let's talk about engineering to make it real, right? Like we all know the complexities of our own environments. So with the data coming in, the inventory of detections we have, the complexity of detections, it brings its own complications. So we implemented some engineering optimizations, and I would like to share some of those with all of you. So the first one is our Spark Compute. So our detection inventory has a mix of lightweight detections, for example, like single event matches. Like those are very fast. But a bunch of them are pretty complex detections. Like we are running regex operations across time windows. So these are varying degrees level of compute that's needed. So we implemented job segmentation. So across different dimensions. It could be depending on like the input volume coming in and the complexity of the detection itself. And sometimes the latency needs, like we don't need every alert to be like next second. What this gave us is isolating the workloads. So we can fine tune independently, both at the detection and the cluster level. And we can mitigate the resource contention and make sure that the platform as a whole is working as expected. The second thing is delta table tuning. So it's important that we tune delta tables to support your workloads. So we optimized, for example, we partitioned our delta tables for example, like on the day basis, on the hour basis, because we are talking about like huge data coming in, right? So we want faster reads. So we did all that optimizations to help to make sure that the detection engine is able to stream read, or for any scheduled runs, it can retrieve massive amounts of data very, very fast. The second is checkpoint. So in Spark structured streaming, checkpoints are important, right? That's how Spark knows, that's how offsets and progress markers are maintained. But we also know the production realities of a checkpoint. For example, whenever you have like a schema drift, which is pretty natural in our worlds, or any new detection that's introduced. So checkpoints will become a bit interesting to handle. So we added smarts to our framework to handle this gracefully so that we don't do like a massive historical reruns of all the data in the lakehouse. And this really gave us like the resiliency and recovery that we need. Third is Databricks runtime. So two things I want to call out here. One is the Photon engine. So if you have like a massive CPU intense operations, you should try Photon. So it's an amazing runtime environment that really gives you a performance boost in terms of running your workloads. Especially like if you have like a complex regex operation across like a wide time window data, which is CPU intensive, Photon really helps. Second is Spark UI. So 2 words for Databricks Spark UI, real-time, responsive. So it gives us real-time operation insights that we need to troubleshoot the environment. For example, like skew tasks, memory strains, et cetera. And it really helps us with like stabilizing our platform and fine-tuning our detections and clusters. And finally, the pre-built views. So let's say we want to do a rare event analysis. That's a threat detection we have. So that means we have to understand how an entity behaves over a period of like 90 days, right? But that's a massive amount of data to bring in every time a detection is running. So we materialized some of those things, and we run them in our environment to create these aggregates, and we store them as a dedicated Delta table in Delta Lake. And these tables get injected into your streaming workflows as needed, massively reducing your latency for the detection and also the compute overhead that you need. So we talked about architecture, we talked about engineering. Okay, what did we do for migration, right? So on the left, we had like our legacy platform running detections as batch mode. On the right, we had this shiny new streaming detection platform. But in the middle, we had like, we had to do 3 things to move hundreds of detections in a pretty, very fast way. So authoring, validation, and deployment. Those are the 3 things that are needed. So the first is like, how did we author and validate? So our threat analysts used Databricks notebooks heavily in this whole process. And we plugged in the detection logic, and we were able to develop and test the rules directly on our standardized data sitting in Lakehouse. And we can iterate quickly on any of the edge cases, like fine-tuning them, and implementing like our suppression and debounce logic to manage the alert noise. So once all that tight feedback loop is done, the detections were moved to production. So this really helped us in like reducing noise and false positives in our system. So this is our deployment at a very, very high level, right? So all the way to the left at the top, we have our detection analyst authoring the detection. Once they finish all the unit testing that's needed, they raise a PR. PR gets reviewed, and once it's committed, it triggers a fully automated CI/CD pipeline for our detection inventory. First, the pipeline picks up the code, builds lints, et cetera, and runs all the automated unit and integration testing. And once the testing and the validations are done, it triggers a deploy. So in this case, in this example, a deploy to Blue. So we stand up a Blue environment, deploy, and we do side-by-side execution. Once all the checks and balances are done, we promote Blue as fully live and operational environment and killing the green. So, but we also know there are always surprises. So if any unforeseen issue happens, we have full ability in our pipeline to do a quick rollback, and for any small window of time, we can do a replay as well. So this ensures that speed and stability can coexist in our environment. So key learnings. So looking back at our journey, there are 3 learnings that our team would like to offer here. First is using software best practices and apply them to your threat detection world. So I think even in the previous talk, we heard detection as code. So it's pretty important to treat your detections as your software artifact. Have your fully unit tests, automation tests, and CI/CD pipeline. That's super important. It was really a forcing function for us to have that high level of quality and scalability across our detections. Second is Databricks runtime. Photon and Spark UI, cannot say enough times like how important they were in our journey. Especially like Spark UI, the kind of operation insights it gives, it's very, very invaluable. Finally, our end users, who are our threat detection team, we designed with them. We didn't design for them. So what I mean is like they were in our journey from day one. They were in our design sessions. They were in our usability sessions. So it was very, very important for working as a team and in building the platform that we need. So closing out, that's how we built our real-time Spark structured streaming engine that's not only fast, but reliable and scalable. That's the end of it. Thank you all for listening, and mic back to Taylor.
Awesome. Thanks, Anil. Appreciate it. All right, so real quick, a couple PSAs. So we've got the networking reception right down on the level 2, where you saw the Rivian, so everybody's welcome to that. Again, just want to reiterate, cybersecurity is a huge growth area for the company this year. It's a strategic pillar for Ali and the company. And our partners, prospects, customers, definitely take this survey because we want your feedback. That's very helpful as we're building roadmap and features. Because it's a nascent area, there's a lot of shaping that we can do with use cases. So, and then lastly, just want to thank all of the presenters. We also have a couple more breakouts tomorrow. I think we have 4 more or so. So Arctic Wolf, Obsidian Security, Point Guard AI, and many others. So check the app and make sure that you get scheduled for those. And that's it. Thanks everybody for coming. Really appreciate it.